This is lesson 62, VHDL example 37. And in this example, we'll write a VHDL program for the edge-triggered D flip-flop that we described in the last lesson. You remember this was the circuit we went through, and it looked like it would produce an edge-triggered D flip-flop. So let's see if it does. The inputs are clock and D, and the output is Q and not Q. We've got the internal signals F1 to F6, F1, F2, F3, F4, F5, and F6. So let's just write the logic equations for these NAND gates. F1 is just not F4 and F2. F2 is just not F1 and F5. F3 is just not F6 and F4. F4 is just not F3 and the clock. F5 is a 3-input NAND gate, not F4 and the clock and F6. And F6 is just not F5 and D. So Q, the output, is just the signal F1, not Q is just the signal F2. So there's the logic equations. Let's simulate it and see what we get. So here's the clock, and here's D. We have D going up and down. And notice that the output Q only changes on the rising edge of the clock, and it gets whatever D is, which is just what the edge-triggered D flip-flop does. So it starts out at 0. On the rising edge of the clock it goes to 0. D goes to 1. On the rising edge of the clock Q goes to 1. D stays 1. On this rising edge it stays 1. On this rising edge D has gone to 0. Notice that Q doesn't change until the rising edge of the clock. D goes back up. Rising edge of the clock, Q gets D. Rising edge of the clock stays 1. Rising edge of the clock, D is 0. Q goes back to 0. Rising edge of the clock, D's gone back to 1. It goes to 1. So sure enough, this behaves like an edge-triggered D flip-flop. And you can look at these internal signals F and convince yourself that it operates the way we described.